Okay, welcome back to your construction materials and testing. Okay, so we discussed before about your Portland cement concrete. Okay, so that is one type of concrete which is a commonly used type of material in construction, and the other one, which is also a concrete, is what we call as the bituminous concrete, or we commonly known this one as the asphalt. Okay, that's the asphalt. So what is bituminous? Okay, so bituminous materials are strong cements, durable, highly waterproof, and readily adhesive. You say readily adhesive, it is an original characteristic of that type of material. Okay, and these are also high resistant to action of most acids, alkalis, and salts. So the interaction of this type of material is not that high. Okay, unlike on the just like the Portland cement, wherein that is not that resistant to these types of materials or these types of chemicals. Okay, so this type of material is widely used in construction projects, from buildings to highways and heavy constructions. So of course it is obvious in our most of our highways here that we are using this what we call as the bituminous concrete or the asphalt pavement. If you might be asking, okay, you might be asking about the use of this on construction, or for example just like buildings. Okay, since this has a characteristic of this one, highly waterproof. Okay, this is one way of, or this is one method, okay, to be used in one method of waterproofing. For example, if you have there a roof deck level of your building, okay, instead of having there a roof, you can actually apply a waterproofing minerals or chemicals, and one type of that could be your asphalt. Okay, so what are the sources of this? So we have what we call as the natural asphalt. Okay, so pools of natural asphalt still exist, just like the pitch lake, which is commonly known as the pitch lake, which is found in your Trinidad Island in California. Okay, LA, California. Okay, we have also here what we call as the rock asphalts, which are asphalt impregnated in porous rocks. Okay, so there are natural asphalts which is already liquid in its original form. That is your just like your pitch lake, or that is the pools of natural asphalt. And we have also the solid, okay, solid form, which is in the form of rocks, and that is found, if you say impregnated, okay, that is a part of porous rocks. Okay, so that is a part of your porous rocks. So these rock asphalts are mined. Okay, these are mined. And then, okay, what is asphalt? Okay, let's try to differentiate what is asphalt, okay, with the other terms, which is almost the same as this, or almost similar. So if we say asphalt, that is a dark brown to black cementitious material, solid or semi-solid in consistency, in which the predominating constituents are bitumens, okay, so which occur in nature as such or obtained as residue in refining petroleum, soluble in most petroleum products. Okay, so that is asphalt. Okay, by the way, again, the main ingredient here is the bituminous material, or that is the what we call as the bitumens, and then that will be an asphalt. Okay, that is a type of bituminous material, asphalt, which is obtained from a residue of refining petroleum. So that is from of course petroleum products. Okay, it is a leftover of the refinery in refining your petroleum products. Okay, so therefore this is soluble in most of the petroleum products. So our solvent here, okay, for asphalt is a petroleum products. However, we have here another one which is also a bituminous material. It is a type which is of material that contains a bitumens. Okay, is what we call as the tar. That is a brown or black bituminous material, which is liquid or semi-solid in consistency, in which the predominating constituents are bitumens obtained as condensates in the destructive distillation of coal. So this type of bituminous material is coming also from coal, okay, petroleum, wood, or other organic material. So that is where this tar is coming from. But the process, the difference, the main difference here is that your asphalt is just a residue of refining your petroleum products, while your tar is made by destructive distillation of it's either a coal, petroleum, wood, or any other organic materials. So that is the difference of these two, and in which resistant to petroleum-based solvents. So if your asphalt is soluble in petroleum products, your tar is resistant to petroleum-based solvents. Okay, so lower content of bitumens compared to asphalt. So that is the other difference. Okay, your asphalt is soluble in petroleum products, while your tar is resistant to petroleum-based solvents. And at the same time, the content of bitumens of these two compared with each other is that your asphalt contains more of that bitumen material than the tar. Okay, so now we have what we call as the liquid asphalt. So that is an asphalt in liquid state. So to eliminate the need to heat the asphalt to a liquid state before it can be used in construction, the cement can be modified into a cutback asphalt or emulsified asphalt. Okay, so if you'll try to recall a while ago in the previous slide, we have the pitch lake, or that is a pools of natural liquid asphalt, and then we have the rock asphalt. So there are forms. Okay, it could be in liquid form or it could be in solid form. But in use in the construction, okay, we will not be using the asphalt in its solid state, because of course we will be using this one as the cementitious material that will bind, for example, the aggregate with each other. Okay, so this will be our binder. Therefore, your asphalt will not be able to perform that characteristic if it is not in liquid state. So if that is solid, it will not act as a binder. Okay, it will just act as like an aggregate. So we need to heat this one, okay, or we need to transform this one into a liquid state to be able for us to use this one as a binder. Therefore, okay, so in doing that, we have this what we call as liquid asphalt, which is in the form of what we call as the cutback asphalt and the emulsified asphalt. Okay, so let's discuss here, okay, on the succeeding topic discussions about these two, okay, and the difference of the two. So if you say asphalt cutbacks or cutback asphalts, okay, the cutback liquid asphalts are produced by cutting the asphalt cement with the petroleum solvent. Okay, these are classified according to the relative speed of evaporation of the solvent. So in transforming the solid into a liquid state of this asphalt, we will be using what we call as a solvent, okay, which is petroleum, since of course we are talking here of asphalt, so that is soluble into a petroleum product, okay, or petroleum liquids. So we will be using petroleum product or solvent to transform that asphalt solid into a liquid asphalt. So that is what we call as cutbacks. So that solvent will try to cut, of course, the particles of your solid asphalt, so that will be mixed together and then it will be liquefied. And then these are classified according to relative speed of evaporation. So of course, your solvent is just merely a solvent, okay, that is not the binder. So if you're going to mix that one on a, let's say, an aggregate to make, of course, an asphalt pavement, then that should be there should be a chance that that should be dry, so that will of course perform its purpose to be a pavement. So therefore, if the solvent, after some time, the solvent should evaporate, so that binder should return to its original state, which is solid, so that it will work as it is supposed to be. Okay, so that type of asphalt, which is the cutback asphalt, is subdivided into classes. Okay, depends on how fast the solvent will evaporate. Okay, so we have what we call as the rapid curing, or we can just denote that one as the RC. Asphalt, cement, and a volatile solvent in the gasoline or naphtha boiling point range. Okay, so that is the content of your, or that is the mixture for us to have a rapid curing cutback asphalt. Okay, your asphalt cement, and then of course your volatile solvent, which is either a gasoline or naphtha or a naphtha. Okay, and then we have here the medium curing, or that is an MC, that could be written as MC. So asphalt cement and a solvent in the kerosene boiling point range. Okay, so boiling point range, same as that, but this time the difference is the solvent. Okay, so kerosene, so medium curing. And then lastly, we have here the third SC, which is the slow curing, asphalt cement and an oily solvent which has low volatility. Okay, so that will now be using a solvent, oily solvent which has low volatility. Okay, so again, rapid curing, medium curing, and slow curing, those are the classes of your cutback asphalts. So what is the reason why we are having this rapid curing, this level of curing? Okay, because of course, comparing it to your Portland cement, if you are using a concrete, okay, there are requirements. It depends on where are we going to use this concrete. Okay, if that is designed to be supposedly to be cured within a long range of time, for that to be able to reach its full maximum capacity or full maximum strength, then that should be slow curing. But if, for example, just like on a busy street, we need to have a rapid curing, then you might be needing a rapid curing type of concrete. So we have this level of speed, or the speed of curing. Okay, based on, of course, that depends on the type of solvent we will be using to create this cutback asphalt. Okay, so again, the only difference there is the solvent. So maybe in here, that the explanation here is that the gasoline or naphtha is much easier or much faster to evaporate compared to the kerosene and the oily solvents. That's why it will make it rapid curing compared to the other, because the fastest the solvent will evaporate, the fastest the mixture will cure. Okay, so that is cutback asphalt. So this is now the second type of liquid asphalt, which is your emulsified, or we call that one asphalt emulsions. So this is the process. So emulsified asphalts are produced by separating the hot asphalt cement into minute globules and dispersing them in water that has been treated with emulsifying agent. Okay, so that is the process of emulsified asphalt or asphalt emulsion. Okay, so we will be using here your we will be separating the hot, or we will be heating the cement or the asphalt cement, so that the globules will be separated, and then we will be dispersing that on a water which is treated with emulsifying agent. So that's why it will make it as emulsified asphalt. So these are your emulsifying agent. So we have anionic or negative charge. Okay, negative charge. Cationic, that is positive charge. So that these are two ways of creating your emulsified asphalt. We will be using an ionic or cationic. So that depends on the charges. And of course, remember about the magnetic fields. Okay, if we have a negatively charged object with a positively charged object, they will attract each other, or they will bind together. Okay, compared of course with the same type or the same charge, they will repel each other. So this type of emulsified asphalt, or yes, emulsified asphalt, works best with positively charged aggregate, which are example are your limestone and dolomite. Okay, these are positively charged aggregate which will work best with your emulsified asphalt using an ionic, okay, or it is a negatively charged emulsified asphalt. And we have here the cationic, that is the positive. Okay, so it will work best on the opposite charge, which is a negative. So that will be our siliceous, or if say siliceous, those are types of aggregates that contain silica. Okay, so and at the same time wet aggregates, so those will be negatively charged aggregates, so it will work best with a positively charged emulsified asphalt. So these are also the classification of that emulsified asphalt: rapid setting, medium setting, and slow setting. Just like a while ago, rapid curing, medium curing, and slow curing. So there are types, subtypes of that. Depends on which type of emulsion did we use, if it is an ionic or cationic. So if that is an ionic, these are the symbols for each of this grade. So RS for rapid setting, MS for medium setting, and slow setting is SS. If you are using cationic, then that is CRS, CMS, CSS. The C there, the only additional C there is, that means cationic. Okay, so that is your liquid asphalt. So general term referring to any pavement. Okay, so what is asphalt pavement? That is a general term referring to any pavement that has a surface constructed with asphalt. Okay, normally it consists of a surface course, or we call that one layers, of mineral aggregate coated and cemented with asphalt, and one or more supporting courses which may be of the following types. So as we know, just like a Portland cement, we will be laying that out as a pavement, but we should have a well-defined base course. Okay, base course. So just like your again asphalt pavement, that also needs a well-defined base course. So again, that is consisting of layers. That depends actually on the design of the pavement, but we need to lay that out on a well-defined base course. So the base course could be an asphalt base, or if you say asphalt base, it is a mixture of asphalt and aggregate. So again, you have the soil which is well compacted, and then you will be creating a base which is a mixture of asphalt and larger sizes of aggregates before you will lay out the layers of your asphalt pavements. So the sub base or the base is still a mixture of asphalt. And then we will be having there a crushed stone, or purely crushed stone, which is of course also what they call this one, well defined grade, which is what they call this one, it's either a crushed stone, slag, or gravel. So that should be well compacted so that your base should be well defined. And it could be, okay, so this is the common Portland cement concrete. So most of the time, okay, just like if you will try to observe on the actual construction, if your Portland cement concrete pavement, or PCCV, is already attained, or it already attained its lifespan, or maybe the surface of that is already has already degraded, then to save us time and of course expenses, or expenses, okay, in constructing or in improving or in developing the pavement, then we can actually make use of another layer, but this time asphalt pavement, or we are going to put an asphalt pavement layer on top of that PCCV, okay, or not PCCV, Portland cement concrete pavement, PCCP, okay. So that is the common as we observe on the actual construction. And then of course your so the main purpose of doing that on the Portland cement concrete is it's either maybe the thickness of that Portland cement concrete pavement is not enough, it's not sufficient for, since of course you know that the volume of the what to call this one, of the car or the O2 traveling right now compared before is increasing, okay. So the volume of traffic is already increasing compared to before, so maybe the design before is not already applicable, so we need to increase the thickness. So maybe you need to apply additional layer which is in the form of asphalt pavement. Or also, if again, as I've said a while ago, your surface is already degraded, we need to improve the surface for, let's say, for that to be, for us to enhance the skidding, okay, or the friction resistance of that, then maybe we will be applying this layer of asphalt pavement. And of course we have also, we can have an all brick or stone block pavements, okay. We will relate this one later on with what we call as the macadam, okay. So those are the types of your bases. It's either a mixture of asphalt itself, or it is just a crushed stone, slag, or gravel, or it is a Portland cement concrete pavement, or it is an all brick stone blocks, okay. So the upper or top layer is the asphalt wearing surface, okay. So the top layer of the asphalt pavements is what we call as the asphalt wearing surface. So this layer is the one resisting the skidding or the friction of the traffic passing through that pavement. It may range from less than 1 inch to several inches in thickness depending on variety of design factors. Okay, so that is the common thickness of our asphalt bearing surface. It's either 1 inch or more or less 1 inch. It depends on the designs. Okay, generally it is preferred to treat the granular material used in bases. Okay, so again, if you have much of that material, then we can make use of that, of the extra, to treat, okay, to treat the granular material base, which could be your crushed stone, old brick, or this Portland cement concrete, so that will now be an asphalt base. Okay, so the most common treatment is to mix asphalt, thus producing an asphalt base. Okay, a 1 inch thickness of asphalt base is about equal to 2 to 3 inches thickness of untreated granular base when it comes to load carrying performance. So your treatment of the base will actually enhance, okay, the performance of our base. So based on this, it says there that 1 inch of the thickness of asphalt treated base is almost equal to 2 to 3 inch of untreated granular base, okay, in terms of load carrying. So when the entire pavement above the subgrade consists of asphalt mixtures, it is called a full depth asphalt pavement. Okay, so when the entire pavement above the subgrade consists of asphalt mixture, it means there are layers. Okay, so the layers of this pavement are purely asphalts. So we call that one the full depth asphalt. But of course, if we have there a concrete or Portland cement concrete before the layer of that, then that will not be a full depth asphalt treatment or pavement. Okay, so this is generally considered the most modern and dependable type of pavement for present day traffic. So that is the ideal full depth asphalt pavement. Okay, all the layers of this pavement should be on the asphalt pavement. So we call that one the full depth asphalt pavement. So preparation of asphalt concrete. So we have what we call as the plant mix, and then the mixed in place road mix, or we call that one the road mix. So it is literal. If you say plant mix, the mixture, okay, the batching of the asphalt concrete is made on plants. So asphalt paving mixtures prepared on central mixing plant, mostly done for high strength desired requirement. Okay, so if we desire on our design a high strength asphalt concrete, then actually we need to batch this one, or to mix this one on a controlled manner, and that should be done on a mixing plant, because the other type of that is the mixed in place, or we will be mixing it on its place, where we will be putting, or we will be laying that asphalt concrete. Okay, so of course, comparing that scenario on the road mix or on the site itself compared to the controlled mixing plant, then of course, if you are targeting a high strength, for us to target that one, we need to control the environment, so that should be done on a mixing plant. But of course, if you are just using, or you just need a common strength or an ordinary strength of asphalt concrete, then we can just do that one on road mixing, or we can do that one as road mix. So actually you can observe that one on actual construction. They are mixing the asphalt concrete on site. Okay, so that is a mix in place or road mix. So mixture is done on site by rotary mixer or traveling mixing plant under moderate warm weather temperatures. So it is important that we will be doing this on a warm weather temperatures, because if you will be doing that one on a cold weather, then as I've said a while ago, we should be applying the concrete mix on a liquid state, so that it will work as a binder. Okay, so for us to maintain that liquid state, we need to have at least warm temperature. Because if you will be having cold temperature, even if you heated that one while you are applying it, maybe without even properly placing, that will now be hardened already. So it will not be properly placed while it already cured. Okay, so that will of course affect the purpose. So emulsified asphalt and cutback asphalts are used in this method of preparation. So that is the use of our liquid. Okay, going back there in our liquid, this one, to eliminate the need to heat. Okay, it is there to eliminate the need to heat. So again, that is very helpful if it is already in its liquid state, because all we need to do is mix this one. Maybe we will just be needing a little bit of that heat to make it warm, okay, to maintain the warm temperature, but that is already in its liquid state, so it will not require a high temperature to convert this one from solid to a liquid state. So it will be easier for us to be using this type of asphalt on a road mix compared, of course, to a solid asphalt. So the solid asphalt, those could be used on your plant mix, because of course in plant mix we can generate high temperature. Okay, we can generate high temperatures in your plant mix. So recycled asphalt concrete, what is this? So combined reclaimed pavements, materials, and new materials to produce asphalt mixture that meet normal specification requirements. Old pavements are crushed into desirable sizes and added as part of the concrete mix. Okay, so we are doing this, okay, most of the time on pavements on highways, wherein they will be recycling. Okay, they will be, for example, that is a Portland cement concrete pavement. They will crush that one so that will become its desirable sizes, which will serve as an aggregate. Okay, additional aggregate. We will be recycling that as an aggregate for our new concrete mix, which is an asphalt concrete. Okay, so that could be done, recycled asphalt concrete. So we have here what we call as the slurry seal. So thin asphalt overlay applied by a continuous process machine to worn pavements to seal them and provide a new wearing surface. Okay, using emulsified asphalt. So in this type of pavement, asphalt pavement, we are using an emulsified asphalt. So we call that one slurry seal. Okay, uniformly graded aggregate from a particle size about the thickness of the finished overlay down to number 200. So of course you know your sieve. Okay, we have their numbers. Those are representing the opening, or yes, the opening of the screen. So again, slurry seal is a thin asphalt overlay applied on a continuous process machine to worn pavement, okay, to seal them and provide a new surface using emulsified asphalt. Okay, so again, that is what I'm saying. Let's say you have there an old pavement, let's say concrete pavement, Portland cement concrete, okay, pavement. Then let's say the surface is already worn out. Then we need again to improve the skidding or the friction resistance of the surface. Then we will be applying this, what we call as the slurry seal. Okay, that is using your emulsified asphalt, and of course using an aggregate which is within this range of sizes down to 200. So asphalt spray applications. So we have this asphalt spray application, and we have these types. So if we will be spraying this asphalt and we will be applying this one, we have these different purposes, and these are what it is called. Okay, so first is your surface treatments, or we call that one, or we can relate that one with what we call as seal coats. Okay, so these are two different: surface treatments and seal coats. So a sprayed on application of asphalt to a surface with or without a thin layer of covering aggregate is called an asphalt surface treatment. So this one is slurry seal. Okay, slurry seal. It is using emulsified asphalt and then of course a mixture with an aggregate size. And then this one is spray. If you say spray, the main here is that we are applying a layer, or we will be spraying a layer of asphalt on the surface. Unlike in your slurry seal, that we are applying a thickness of a mixture of that emulsified asphalt and a range of sizes of that aggregate. Okay, so this is a sprayed on application. So surface treatment is a sprayed on application of asphalt with or without thin layer of covering aggregates. So again, what is the difference of this covering aggregate is that we will just be spreading their aggregates so that will enhance the skidding of our sprayed on treatment, which is your surface treatment. We call that one surface treatment. So it is called an asphalt surface treatment. Okay, so that is your surface treatment. Sometimes these surface treatments are included in the original construction. Okay, so your slurry seal is applied on a worn out surface. Your surface treatment that could be already applied after the construction of the new pavement already. Okay, so once you are done constructing, you can include that already, surface treatment already, so that we will enhance, or we will enhance the skidding resistance of the surface. So the addition of covering aggregate over the sprayed on asphalt restores and improves the skid resistance of the wearing surface. Okay, so that's what I'm saying a while ago. And then surface treatments that have waterproofing or texture improvement, or both, as their main purpose are called seal coats. Okay, so this is what we discuss here, is a surface treatment. And then we have a specific name for that type of surface treatment. If your purpose here is for waterproofing or texture improvement, so if your purpose is for waterproofing or texture improvement, then that type of, or that surface treatment is now called a seal coats. So again, seal coat is just a surface treatment. Again, seal coat is just a surface treatment. Only that this time the main purpose of your surface treatment is for waterproofing or for texture improvement. Okay, so now we have this next one, the tack coats, another type of asphalt spray application, tack coats, and then that will be related with what we call as the prime coats. So we are now referring here to coatings. So tack coat is a sprayed thin coating of asphalt to bind existing in the new pavement. Okay, so this is now what we call as the tack coat. So if you have there an original pavement, and then you are going to lay another layer of new pavement, asphalt pavement, before you will lay that one, you need to treat. Okay, you need to apply a seal. We call that one a seal or a coat, so that it will enhance the binding of the original and the new one. So we call that one a tack coat. So there is an existing. Okay, we will bind that one, the existing, with the new pavement for that we are going to construct. Then we have here what we call as the similar to that, which is a coating. What we call that one the prime coat, that is sprayed on granular base so that it will seep into or penetrate the base and serves as a binder for the pavement to be constructed. So if tack coat is to be applied on the old or existing pavement, this prime coat is to be applied on a base, on the base. So it means there is no existing. So we are going to construct a new pavement. Okay, so before laying out your pavement, we need to treat that one, or we need to coat that one. Or just like in painting, isn't it? The first coat, we call that one prime coat or priming. Okay, so just like in this asphalt pavement, the first coat from your base, or that is soil, let's say a soil or a base course, you need to apply there so that it will enhance again also the binding of the pavement with the base. So that is a prime coat. But if you have an existing pavement already and you need to add just a layer of pavement, a new pavement, then you will be applying a coat there, and then that is what we call the tack coat. So prime coat is if there is no existing, tack coat if there is an existing. Okay, so those are the asphalt spray applications. So this is now what I'm saying a while ago, penetration macadam. Okay, so what is that? So asphalt penetration macadam pavement consists of one or more layers of large size broken stone and rock chips interlocked by rolling. Fluid asphalt is sprayed on each layer and it seeps into or penetrates the layer to bind the stones together. So this is what we call the penetration macadam. We are not going to mix the pavement. Okay, we are not going to mix the pavement with an aggregate and then pour that one. No, the penetration macadam is done in a way that we will be laying out, okay, the big size or the large size stone, rock, or whatever that is, which is already rolled. If you say rolled, that is already compacted by rollers. Okay, so it means that it's already in its place, but we will just be pouring there a liquid asphalt itself so that it will seep into those interlocking rocks. Okay, so that it will enhance the load carrying capacity of that. So that is penetration macadam. That is the difference of this with the convention asphalt pavement. convention asphalt pavement is that you have these small sizes of aggregate. We are going to mix that one. We are going to batch that one with your asphalt cement, and then we will be pouring that one. No, your asphalt or your penetration macadam is the other way. We will be laying these large size stones, compact that one before you are going to pour the liquid asphalt. Okay, so that is penetration macadam. So commonly this is done on massive. If you say massive construction, that could be a dam. Okay, if you want to enhance the if you observe the dam, what we call this one, a bank of the dam that is either composed of a soil or a rocks. Okay, so if you want to improve the waterproofing of that, or the level of impervious of this what we call this one bank, you can apply a liquid asphalt, and then that will serve as that will act as a penetration macadam. Okay, so roller operation. So rolling should start as soon as possible after the material has been spread. Okay, so again, as I've said a while ago, we need to be laying this as fast as we can. So while the temperature is a little bit warm or hot, so that we can lay this one correctly on its proper place, and then before that we'll start curing. Okay, so rolling consists of 3 consecutive phases. So we have what we call as the breakdown or initial rolling, that compacts the material beyond that imparted by the paver to obtain all the density it needs. So that is the initial or breakdown. And then we have what we call as the intermediate rolling, that is to densify and seals the surface. So of course the first one is to attain the desirable or the desired density. Okay, and then now we have the intermediate rolling, or of course that is to seal the surface, and then finally the finish rolling. So this is the final finishing, or the finishing. Removes the roller marks, of course, because while we are rolling that one, there will be marks of the wheels of our compactors. So this will be your last what we call this one phase is your finishing or your finish rolling. Removes roller marks and other blemishes left from previous rolling. Okay, so these are now your deficiencies in asphalt mix. So it's either your mixture is too hot, it's either that is too cold, or your mixture has too much asphalt, or that has too little asphalt, non-uniform mix, excess coarse aggregate. So there are a lot of coarse aggregate compared to what is required, excess fine aggregate, and then excess moisture. So there might be moisture in addition to the what to call this one, asphalt cement, and then others. There are a lot of that, but I will not be discussing this, of course. That is of course as a research for you, okay, to understand more about the asphalt. So what will be the effects of these deficiencies in asphalt mix of course to the resulting asphalt pavement. So this will be the assignment. Okay, so this will be your assignment. So if you have any question regarding this discussion, then you can comment below, or we will be discussing that one on the live meeting. So thank you very much for watching.